This will take a while to download in the lab, so hang on while I show you this really quickly. So this book talks about virtual technologies, and we look at things like the cloud and what it actually is. We've actually experienced a little bit. You guys have all seen VirtualBox, right? We've all made you torture you a little bit with it. I made you get an install and actually install a copy of, I think we did Ubuntu in here if I remember correctly. Well, there's a couple of other ways to do that. So one of the benefits or the great things about something like VirtualBox or VMware is I can use pre-compiled versions. In other words, somebody's already downloaded and installed it and got it running the way they want it to, and I can actually use those versions, or I can do that on my own. So I'm going to show you a couple of places, and we're going to download one and start downloading it called Pop! OS. And we're doing this in the lab, but I want to show everybody else what we're talking about and what we're looking at. So I'm going to open up another browser window here. And just to show you some of them that are out there, I'm going to type VirtualBox images. And you'll see that there are several sites that have VirtualBox images. And so the one I want to look at is osboxes.org. So this site, when I look at it, says, oh, they of course want my donation, and good luck. So most of these are free, and so they are going to hit you up for, hey, can you please contribute? So this particular site says I can download images for any of these things, and they're already pre-compiled, and I'll show you what they look like. So what I would like us to find is, and you can do either one of these, and they work very similar. So down here should be one called Pop! OS. If I can scroll down far enough. Oh, this one doesn't have Pop! OS. All right, never mind. Ignore that. We'll just do Elementary OS. I thought this one also had it. So if I open that up, it says, all right, I'm going to download that VDI image. Okay. That VDI, if you think all the way back, and I know it's been a while, when we created our own copy of Ubuntu, one of the ways we could save it was as a VDI image or a virtual desktop image. And so we're going to actually download that. And I know it's going to take a long time in the lab, so I'm going to start it today, and I'll show you how we implement it then on Wednesday. So if you will click download for Elementary OS, and this is fairly large, so it's got a couple of things in it. So it tells you about what Elementary OS is. Notice it says it's an Ubuntu-based one, but not like Ubuntu. So you have a couple of different options. So notice it actually tells you you can get a VirtualBox version or VMware. Well, we don't have VMware because we're cheap. And then it does a couple of things here. It says here's a size, and then it's got a code so that SHA-256 is what we call a hash. In other words, we can check and see if that download is good by using that hash. But what I would like you to download is that OS 5.1.4. So I'm just going to click download. And since it's fairly large for our ability to download in here, I'm going to have you download it, and then we'll use it on Wednesday. So it will take, with all of us in the lab doing it, it's going to take a while for it to actually download. So in this case, it lies and says it's only a couple minutes, but I'm going to suspect as soon as everybody starts downloading it, that will jump up significantly. And so I'll try to show everybody online also how we can take a pre-compiled image and we can actually use it. So notice our time starts to go up. All right, so now let me segue back to important material at hand. And that is that idea of virtualization. So we're going to show you what goes on behind it, and we talk about cloud computing. Cloud computing really means that you're putting stuff on somebody else's server. That's all it means. It's a server that you don't directly control in most cases. So we want to talk about virtualization first, and so we need some terms so we're all on the same terminology. So virtualization just really means that we are doing a logical or a virtual version of something rather than a physical version. So on your home computer, you installed Windows or Mac OS and it's on the physical hardware, one copy. With virtual, and we've all kind of used VirtualBox, at least in the lab, and hopefully you've seen some in the demonstrations, you can install multiple versions of an operating system in that kind of virtual environment. So the host is where we're putting that. So in this case, if you're putting VirtualBox on your computer is the host. A guest is each copy or each virtual machine that's running. So my computer at my house, I spent way too much money and I built up a Threadripper just because I like to run multiple operating systems to experiment and play around and do some looking at different things. And so at my house, I have a very powerful desktop computer, and I will at sometimes be running 6 to 8 different guests at the same time. These computers in the lab, if you try to do that, would come to a creaking halt, and we'll show you where some of that happens. But it's not uncommon for a server to have 20 or 30 or 40 hosts running or guests running at any given time. And that's kind of the new model we've developed, is we can have these guests running. And so if the Peru State College website's on a guest, that page gets hacked or something happens, we just go back in time and restart that guest at an earlier time. Or if that computer, the server that it's on, gets damaged, we move that guest to another server, and we don't even realize that anything has happened to it. So the thing that controls everything is called a hypervisor. So the hypervisor, so in our case, when we download VirtualBox, VirtualBox is the hypervisor. There are others, and VirtualBox is really not a designed for production environment, but it's a great for experimentation environment. I'm not going to set up a server and use VirtualBox to put up a bunch of Windows Server systems, but I certainly will use some other tools that we'll talk about, VMware, or in the case of Microsoft, we actually can get a free hypervisor with their system. So hypervisor is what creates and manages those VMs, manages those resources, manages the connections to the outside world that we're going to talk about here in a minute. So physical host, and maybe this picture, because I know this is a little strange to think about, but it's like you're having multiple servers all running inside of your computer. You have some limitations, though, and one of those limitations is your home computer typically only has one physical network interface card. Now, on a server, we run typically a multiple connection interface card, and we run much faster ones. And so you'll see one of the differences here. So there's two basic ways to run a hypervisor. There's type 1 and type 2. Type 2 is what we're running. So in other words, we've got Windows running, and our hypervisor sets on top of that, and then has our guest operating systems. That's great for us on our home computers and the computers in the lab. In the server environment, most of the time we actually run it as a type 1. The hypervisor is installed first and is really the only thing that we call bare metal. In other words, it's the only thing that actually interacts with all the hardware and software pieces. And then the operating systems are all sitting inside of VMs. So we install VMware and then all the operating systems. So if we install Windows Server 2020, it's installed inside of one of those VMs. It's not installed directly on the server. And so that's what you're seeing more often. So there are advantages to both types. This obviously is going to take more resources because you have the operating system running and then an operating system running inside of that. It also doesn't allow that hypervisor to control that box as completely as it does a type 1 system. So type 1 systems, servers, type 2 systems, think about your home computer or workstation. So VMs you can customize in, and we've already did that a little bit when we ran through the install, is you can say how much memory do you have. So you can carve up that memory. So on a server, a lot of times we'll have 256 or more gigabytes of RAM, And we can carve up that RAM and assign chunks to each operating system so they know how much memory they get, how much hard drive size, what kind of processor. So sometimes we even do virtual processors. So what type, how many CPU cores are they doing? So a lot of servers have 32 or more server cores. And you can assign them. So maybe you can assign a virtual operating system. You can assign it 8 gigabytes of RAM, 1 server core, or 2 server cores. You can give it 20 or 30 gigabytes of space. So you can set those parameters of what you are allowing each one to use. You can generally go in and change that even at a later date. So if I need to add more resources. So this is one called VMware, a screenshot from, and an older version. It doesn't look quite like that now. But here you've said, all right, I'm giving this server, I'm only giving it 1 gigabyte of memory. Well, that's not a lot, but that's what its recommended minimum is for this particular system. And so you say, all right, I'm giving it 1 processor. It's got a fake DVD player. We'll talk about that network adapter. So all of these controls and pieces you can change on the fly. So I can say, well, I really need this to actually have 8 gigabytes of RAM. So you can test. Hey, I bought the new version of Windows. I want to see what happens if I really try to run it in 1 gigabyte of space. Does it work? How does that compare to if I run it in 8 gigabytes of space? Does my software crash, for example? So there's some of the controls that we can do that. Where the confusing part comes in is this, the network connections. How is that virtual machine connected to the outside world? So the virtual machine has a virtual network card. Okay. And that virtual network card can run in a couple of different functions. So it's easier probably to show you this. This maybe makes more sense to see it on a slide that looks like that. So each one of the virtual machines, in this case, has 1 virtual NIC. I can have multiple virtual NICs, and there's some reasons, but probably a little outside of where we're going here. And then inside of that host, so VMware, virtual machine, any of those, have a virtual switch inside of there. So in this case, all of the VNICs are connected to that virtual switch, and they actually feed data out through 1 physical network card. Does that look like it's going to be a bottleneck? You have 4 servers, in this case, all trying to run out of 1 network interface card, physical card. It can be. And so this can be one of the limitations or issues we're going to have. So on your home computer, ignore this second NIC. This is what you're almost always going to have. You only have 1 physical network interface card on most servers. So we can change that up a little bit, and we can actually do something a little different. So in this case, here's our virtual switch, and because this computer has 2 physical network interface cards, I've assigned VNIC 1 and VNIC 2 to that physical NIC, VM 3 and 4 to this physical card. Most of our servers, when we buy them now, have generally 4 or 8 network interfaces, and it's partly because of this that it makes a lot of sense that we can do that. You also have to figure out, all right, it's connecting. What kind of connection do I have? In other words, where am I getting all my network information from, and how am I connecting to that network? So the way that we connect most of the time, so let me show you what's typically done. So here we have our DHCP server on our network, just like we have in here. And their VMs are connecting to this virtual switch. But that virtual switch just passes it along to a physical switch. And all your information, so what's your IP address, how you're connecting, all comes through our existing network. So to the rest of the world, it's literally impossible for them to tell that you're on a virtual machine. So this is really good. When we want to put up servers, for example, we do this. So to the outside world and even to our inside network, we don't know that those are virtual machines. And quite frankly, what we typically do is we actually only have a VM running to a physical NIC, VM to another physical NIC. So they're each got their own connection. So we try to do that. That maximizes our bandwidth on that server. So that is what we call that bridged mode. Our virtual machine is bridged to our regular network. Some of the other models that we're going to have. So this is a bridged how to do it in VMware. We're not going to show you that or worry about it. But the other way that we typically see is called NAT mode, or natural address translation. That's what we're doing right now when we do our VirtualBox. VirtualBox can work in bridged mode, but we don't do it a lot. VirtualBoxes tends to be, we're doing experimentation. So NAT mode really works fine. So in NAT mode, it gets all that information from that host computer, and really, from the outside world, we only see that host computer. We don't see all the individual data streams and individual or guests in there. So the hypervisor does all of these things for us, translates all our information, and it really is, that line is appropriate. It says, do not need to be accessed by a known address. In other words, we're getting a virtual address. So if I do an IP config in this lab, one of the things that you will see is you get one that's a 192.168.56 address, and it'll show up on that IP config all. And that's that virtual address that's been created by VirtualBox. That's that NAT mode. That works for us for a lot of stuff, but if we're going to put servers online, we really need to have this idea that they're joining directly from virtual to the NIC, or even a couple of devices through that virtual switch, and that they're getting all their network information. It comes out of our existing system, our existing server. That way, if I move that virtual machine from one computer to another, it's still going to get the same information. And it's on our network like a part of the network, not being virtually communicated with through that NAT. NAT is great. It hides details, but for the purposes of a server, it doesn't work really that well for us. So this is that idea, that NAT mode. So this, we have inside addresses that have nothing to do with our physical address, because that computer changes all the details for us. It hides it. That natural address translation feature puts it in there. So we can run any address we want inside, any addressing scheme we want. It doesn't see the physical network we have. One caveat with this. We build this network in here, we play with it, we experiment with it, and by golly, that's great. It's a great place to do that. We build a whole range of addresses in there, and we've got a network of 3 or 4 guests ready to go. And we think, all right, now we're going to switch that from NAT to bridged mode and put them onto our network. If you do that, you need to be really cautious and make sure that you haven't created some kind of address overlap. So if you've set any static IP addresses or anything in there, and then all of a sudden you put it onto the live network instead of through that NAT, you need to be careful, because you can create some issues where you have duplicate IP addresses and things. So that's where that cohesive and a coordinated network addressing scheme really makes a lot of sense. So here's how we can actually select. So when you did VirtualBox, you got a screen very similar to this, or can get to it, and we can actually change it, and we can change those adapters. And notice in VirtualBox, we can run 4 virtual adapters, and it's attached via NAT. If we pull that down, we can do bridged mode and a couple of other options. So one of the other options we can do is something called host mode. So host mode is interesting when we want to do a lot of experimentation. It never leaves, it never connects actually outside of our system. It stays only in here. So if I'm doing security testing on software, this is a great way we can do it. It never leaves the physical NIC. It can't hit it. It also means some weird oddities if I want to do software updates and things, but it essentially isolates it. And the physical network never touches the virtual network. They're not connected. It's almost like you pulled the plug on it. So the VMs inside of here, so VM 1 and 2, everything connected to that virtual switch, they can still communicate, but they can't get outside. So we use that in some isolation testing, trying to see what's trying to send out data. One of the ways we do that is we know that there are a lot of programs that like to send out data. This is a great way we can do that and capture that data attempts. So if you've got Apple software tends to phone home to the mothership a lot. We can try to capture that data then using an isolated mode or a host mode. So why do we go to all this effort to do that? Well, there's a couple of really good reasons. One, instead of having 25 physical machines, and again, if it weren't for COVID, I'd let you guys all go back in my lab in the back and see, we used to build physical servers for every task we did. So if we wanted to have a database server, it was on a physical server. So we bought a lot of hardware. Now with virtualization, we can spin up 20 different types of servers on one box. Now, we have to add a little resources to that box, but the cost savings are really tremendous. So cost and energy, we're using less boxes, less energy. It's efficient. If something goes wrong in a virtual machine, we don't have it doing usually one task. So we might have a database server. We might have a time clock server. We might have a server that's just for file folder storage or data storage. We can then say, oh, that particular machine has got an issue. Let's work on it. We don't bring down the rest of the network. And we have less physical resources to do that. It makes for some really great backup options. So things like Veeam, for example, I can back up every 20 minutes if I wanted to my data on that server and my server by taking snapshots and rolling it back like a clock if it gets compromised. So if we have one of these ransomware attacks that's happening a lot right now, we could roll it back. So backups are good, recovery's great, we can replicate it. So suddenly we have a need for multiple copies of file folder storage. Maybe we've increased our size of our company. I can roll out additional copies. If I'm using something like VMware, some of the bigger ones, and I have something like vMotion, I can actually move them while they're running to another server. It's really kind of a cool thing. So I have a server that's got a physical hardware issue and I need to turn it off to fix it, or maybe even upgrade it to a new one. All I do is use something like vMotion. I slide them over to another server temporarily, replace the server, update and put on the VMware host, and then I slide those back in. So it's really efficient from that. So here's some downsides. Well, downside number one. Because I'm on a virtual platform, I am not as fast as I am if I'm physical. If I need the ultimate speed out of a server and processing power, I want to be on bare metal. So there's a performance hit because of those virtualization tools. It's more complex to map out, draw out, license. So in the case of things like Microsoft, the licensing can get very expensive. VMware is expensive. So I have a lot of licensing costs. And here's the dumbest thing we can do of all. So we said, oh, we can consolidate all those servers down. We consolidate them down to a single server. That server physically breaks. You've taken out everything. It's that single point of failure. But I have known companies when I walk in the door and I talk to them, that's what they have done. And then I went, oh, that's not great. That's not good. So we always want to have something to eliminate that single point of failure. So I almost always advise that you're going to do this. And hey, put it on 2 servers. You may have one that's idle for a lot of it, or some VMs that aren't as active as others. But if worse comes to worse, I can get them all up and running on one physical machine. So you want to eliminate that single point of failure. But I think the licensing and the complexity, this is new for a lot of IT staff. They don't understand how to do it. It's very scary. And that virtual thing kind of makes your head hurt when you first start trying to draw it out and going, all right, so I've got a server here, I've got a VNIC here, and I've got to connect to a physical network here. And if I'm not comfortable mapping that out and trying to understand how it works, then I've added a lot of time and overhead. If I have to bring in other companies, if I have to look at that licensing cost, and this company isn't willing to shell 20, 30 grand out for VMware licensing, and it's not willing to shell out all the money for licensing for whatever other products we're using, for example, Microsoft. Now, I will say Microsoft Server has made it a little easier, because one of the things they do is they allow, if you buy a single copy, a license of Windows Server 2020, 52, whatever's out there, they usually will allow you to run 2 copies of that at a single time, legally, depending on which Microsoft rep you talk to. But at a minimum of about $1,000 a license for Microsoft Server, that licensing gets a little complicated. It's made even more complicated by the latest developments from Microsoft, where they want to charge you on a subscription basis, based not only on how many CPU cores you have, how much memory you use, how many instances you have running, and apparently how high the tides are in Shanghai. I'm really not sure. There's some weird things in that licensing. So it can get expensive. It can get really expensive. But the upsides, I think, outweigh that. And especially that ability when we have so much ransomware, so many different pieces of malware out there, and we have developers trying to upload code that really hasn't been tested very well. If I can isolate that and stop it immediately, and I can roll back, or I can replicate my data, I can hopefully save a lot of things. And so we talk a lot in cybersecurity next spring about those kinds of issues. And so I was supposed to have an appointment last week at the medical center at University of Nebraska Med Center. Guess what? They got hammered by a cybersecurity incident at the Med Center. And they had to call me and say, we can't have you get your appointment because they've shut down all of our systems and we can't see your data. Now, the fact that they turned it off is probably good rather than just continuing to operate. But that virtualization, and I guarantee they have a ton of it, is what allowed them to do that, find out what happened, and then come back up as quickly as they did. If you're not virtual, in a lot of cases, it can take a much longer time. If I've got to completely go to bare metal, reinstall everything from scratch. And so I look at something like Beatrice when they got hit a year and a half ago, 2 years ago. Beatrice, the city, was down for over 3 weeks. And they, in fact, brought in our state, the National Guard actually has some cybersecurity response issue or abilities. They brought in the National Guard, and it still took them 3 weeks to get back up. So it's that difference of how do I recover? And it's not, unfortunately, when you're going to have an incident, because we know it's going to happen. It's either going to be a security incident, you're going to have a hardware failure, software failure, something. How do I go about and recover from it? And so that's one of the greatest things that's in there. So we've got these virtual pieces now. Now we can do some other things that are virtual. And so one of them that's starting to creep in is the idea of things like virtual firewalls, virtual routers. Now, My brain has a little hard time thinking that this is actually a good idea. And I know that's weird. But a virtual firewall, you put the firewalls in a virtual machine on an inexpensive server. Okay. But now we also have virtual routers, so same kind of idea. And so we're putting those in a virtualized environment. Okay, I can sometimes see it. I haven't quite convinced myself this is always a good idea. But sometimes we can migrate them, and that's really a true point. But specialized firewall hardware and specialized router hardware typically don't fail, and the code is written a little tighter. Usually. Used to be, hopefully. Not necessarily. Now, the biggest advantage is I can scale it much more quickly to size. So I don't have to say, oh, I've got an Meraki MX60, but now I need to scale up to an MX84, and I have to change out hardware. And so some of that we can go, oh, I'm going to pull down a slider and give the firewall more resources. I see some advantages to it, and it's happening whether I like it or not, so it's probably going to happen. So if we can do all of these, now we're starting to put all these pieces together. So we have load balancers, storage, virtual servers, firewall. Again, that issue of licensing rears its ugly little head. We have additional latency or an additional overhead because of all those devices in there. And I love this last line because that's me. They're not comfortable using a virtual firewall to protect that entire network. I'm not yet, but I think at some point I will be. I'm old. I don't change my mind as often, but I get there slowly. The licensing gets to be pretty expensive. But what we're heading to is this idea of this. A storage or a virtual network, if you want to think about it that way. So, software-defined networking. So everything we do is done in software versus hardware. Now, at some point it's on a hardware somewhere, but it doesn't matter as much. We can move it around. Where I'm a little afraid of this is this idea here. So it integrates everything together. So that's good. We can see the entire network. We can control it. But it also gives that single point of failure. If you can manage to figure out that software-defined networking and a flaw in it, you've gotten into the entire network. In fact, I tend to be the kind of guy who puts in two different firewalls from different manufacturers running different code versions just to avoid some of those issues. So I'm a little more paranoid than some people. So how this looks, and this is just kind of a weird drawing to explain, that control plane, in other words, how we control each device. So here our switch and our router and our virtual switch and all those are controlled with a different control plane. In other words, but in our software-defined network, everything is controlled with one application or one piece of software. And so my brain, because I always kind of spin towards the dark side, go, man, so if I could figure out an exploit in this, not only do I control your switches, and I control all your VMs, and I control your routers, I can hide in there for a long time finding interesting data or corrupting data, and you're not going to see me because I'm hiding in that software-defined network plane. So when you do this, you're putting a lot of trust in some of those vendors. And my dark side, that evil side that makes me do bad things like make printers print, looks at that and goes, ooh, I kind of want to play with that and see if we can exploit that. So that's my side of why that might be a bad idea. Logistically, it does make some sense. So in this case then, if you look at this, you have that control plane, makes routing decisions, switching, blocks, in other words, on the DNS, what can and cannot go out, does the forwarding. And again, my little spider sense says, if I can get into that, I own your network. So if I get into this, I own United Bank or whatever happens to be using this. So I'm hoping that those administrators are paranoid and not just buying off on a company product, because I think there's some things we need to worry about. Because if I control everything on this data plane, I can insert myself in and I can grab copies of that data, and maybe I'm just slurping away at your company and I'm in there for 6 months grabbing all kinds of data about your company before I decide to run an exploit of some kind. And it may not even be a computer exploit at that point. What I may do is, because now I've got enough knowledge about your CFO and how they send emails, and I'm inside your network, so I can send an email that looks like it comes from inside your network, and I tell that CFO in an email, hey, we have a venture going on in South Korea. We need to wire $10 million to this routing number to start that. Comes from inside my network, so nobody's bells are going off. And I can use some software to change my voice a little bit now, so even set up a fake spoofed phone call to that CFO, to the vice president or whoever it is I'm pretending to be. So I'm hoping companies are looking at that really tight. And we'll talk about all of those in other courses, because I will show you how some of those things have happened, some workarounds. But it does frighten me a little bit. Because the average time when somebody says they're going to exploit your network, they're not in there a day and get caught. They're in there about 6 to 9 months. And so I think this is just opening up a giant can in some cases. So what's the primary advantage? Makes the network techs and the admins' lives easier. It does. I like it. I've used it, and I showed you the Meraki pane of glass, which is a software-defined network that I can control switches, and I can control the router, I can control the access point. What I don't show you in there is that's all hiding behind another router that's got a firewall on it, and I control that pretty tightly. The other reality is it's a library, and I don't have anything really critical hiding behind any of that. It's mostly just to provide internet access. All the data is tucked away somewhere else, and I like to think you can't get from one to the other, but I also can think of ways that I might want to, never mind, I shouldn't think about that now, I've just scared myself. So, it is a way we can implement much more sophisticated network. We can sometimes use it doing off-the-shelf equipment instead of specialized routers. So for some companies it might hold some cost savings. I think it has a lot of potential. I think it's a little frightening. The other reality with it is that we can also then, it says, and I love the way they word this, we can take care of resources not within our local network also. And I showed you that by going out to that Meraki network that I'm going through. I can get to any of those devices I have on there, and I'm not on my local network. I'm doing it from outside. And so I'm punching a big fat giant hole in there. And so I think of companies, Shell Petroleum, for example, that uses, I know what they're using for some Wi-Fi devices in all the Shell gas stations across the country. One interface, so one person forgetting their Wi-Fi login, or they're misplacing their login or doing something dumb, admin password or something, and you have access to every Shell gas station into their network. Ooh, maybe not that great. So we have to look at those trade-offs. The flip side of that is, though, if I had to do each one separately and I had 400 passwords to try to manage and login accounts, is that any safer? Have to manage some of that and see what's going on. But there's some other areas that are a little even more frightening than that. So let's talk about the cloud. The fluffy clouds that are all around us. Fluffy clouds, we use them. If you have an Apple phone, I'm going to guess you're paying some money for an Apple cloud storage. It really is that idea that we're putting our data, our applications, services, functions on somebody else's computer. So it gives us a lot of really good things. So I'm able to build a data center, and I'm able to sell those resources to other people. And so I really get that efficiency. In other words, I can build a giant data center that's very efficient. I can sell off portions of that. I can sell it by use. I can sell it by how much bandwidth they use, however, whatever model I want to use. There are some security advantages to it. So rather than build my own server and try to maintain it, I've got a team of security professionals maintaining it. The biggest advantage is I can spool it up and down very quickly. So as a customer of Amazon Web Services, I can increase my web portfolio quickly. So suddenly Peru State College doubles in size, and we're using Amazon Web Services to host our website. All I have to do is up my bandwidth and up my ability to connect. I pay more, but I'm able to scale that up very quickly. On the other hand, our tuition goes down, or our enrollment goes down, and I can make it smaller if I needed to. I can scale up and down very easily. And I don't have to invest immediately in all this storage, hardware, physical pieces. That part's really good. Somebody else is doing a lot of that stuff for me. And we're going to look at all the apps and different things you can put on it. So it's not just storage that we're talking about. If it makes some sense logistically, and sometimes we run those numbers, it certainly did for Netflix. Netflix, everything except the actual video streaming, all of their website, all of their databases are all stored on Amazon Web Services. It makes sense in a lot of cases. We can scale. We can get that service we need very quickly. Your Blackboard that we have for our campus, we can scale it very easily because it's actually hosted on Amazon Web Services through Blackboard. They used to have their own web server and their host, and they're transitioning people off and going to shut down their own data center. It was very expensive for them to host a data center, and as scary as this seems, all of Blackboard was really hosted on one data center out on the East Coast. And hurricanes had an impact on that. So now it's hosted on Amazon Web Services, distributed around the country. So we can go all the way out to, we can now create desktop environments. And one of the great ones for that is Azure Dev Services. So Azure is Microsoft's answer to Amazon Web Services. And we can actually run virtual desktops on there. We can do our Active Domain. We can do all of our provisioning. We can do about anything on Azure. I don't need to have you set at a computer. I can get you on whatever platform. You connect into Azure, and you have your own desktop inside of there. So my data all stores locally there. That's pretty cool. So I have that Azure. I've got Microsoft's development team there. It backs up my data really nicely. So that works really well. It gets expensive, and I've looked into it trying to do it in our lab, because we do have some ability with the package we buy to do a little bit of that. But so this is what we can do. We can do literally everything. So it doesn't matter if you come in on your smartphone, a tablet, a Chrome tablet, whatever, you come in on that virtual server and you can get all of your stuff. You can get security, you can get backups, you can get your desktop. And so in COVID, this has exploded because a lot of businesses needed some way to have you work at home and work at home securely. We didn't want to email you a client list, or in healthcare, email you a list of all their diagnosis codes. We wanted some way to do it securely. And this idea of cloud hosted on their end makes some sense in that particular case. So you can have a virtual desktop. Every piece runs inside of there, works really nicely. So we have a ton of terms in here, and there really is kind of a gray area on some of these. So what do we call, I'm going to generically call it all cloud computing, and I tend to include software as a service kind of as an overarching thing, because when I look at it, this is what we're really looking at. So traditional means we run everything on our own side. So we have servers, we have networking, we have our OS, our own virtualization inside maybe, data storage, our applications, everything. This is traditional. This is old-fashioned. There are places that still do this, and there are some reasonable reasons for doing that in some cases. Then we move up the scale just a little bit to infrastructure as a service. So in other words, our servers, our storage, our networking are all really done remotely. So in other words, we log in through Azure or a different cloud service. Our files are stored there, but not all of it. And our applications are still run on our local computers. Kind of in the middle. Platform as a service. Well, now we include the operating system a little more. But software as a service, I think, is where we're growing the most. Everything is hosted by the vendor. All we, in most cases, have to do is go to a browser and go to a website and sign in. Google Docs is a great example of a software as a service. I don't have to do anything. I don't have to have a server on our campus. None of that. But I have some trade-offs with that. Do I have as much control? I think my data is secured because I trust Google, but am I absolutely sure where all that data is at? And so there are some places have a lot of difficulty with this. Governmental organizations that store data, medical data tends to not be out there, and part of that is a lot of the laws about medical and privacy data say you have to know exactly where that data is at, and you have to make sure it's secured, and we're not necessarily there. And then this is a newer term that's come out, this idea of XaaS, anything as a service. So everything we want to do. So email, cloud storage, databases, games, customer relationship management, MyPSC, Blackboard, everything you interact with, you walk into a website to do. You're really doing it on the web. You're not sending out a, hey, I need to go to the data center and do that. Scalable, great. There are a few things that are even better. So this idea that more users, so software as a service, that means everybody can get into it. So if I say, hey, go get an email account for a project, or I'm going to get a Google account, we can do that really easy. On the other hand, if I said, hey, I need an account tied to just Peru, it's going to take me a little longer to do those kinds of operations. So software as a service is where we're headed in a lot of applications. And for a lot of us growing up, this is new. For those of you that are under 25, this is nothing. This is like, oh, I'm used to all this. Everything runs on the cloud. And so we do have a couple of other models. So we have a public cloud. In other words, everybody can get to it via the internet. Now, not everybody can log in, but the transmission is over the internet. We have a private cloud. So here at Peru, there is a tiny little private cloud called Nimbus. And Nimbus allows me to do my time clock and a couple of other features. I'm not sure if any of them actually work at this point. But it's mostly so I can do my time clock, or at least that's what I use it for. And I can see some data files we store on campus. It's a private cloud. It's hosted here, but I can get to it from anywhere in the world. So you may have a community cloud, so multiple organizations share something. So MyPSC would be an example of a community cloud. MyPSC exists in slightly different forms at the Med Center, at UNL, at UNO, at Kearney, at Wayne, at Chadron, because we all went together and built a community system. So it's shared between multiple organizations, but they have common core data needs. So, and then if we model any other thing, it's kind of this hybrid kind of thing. So our MyPSC is probably the best example of that community. So it's actually hosted in Lincoln, but it has a remote backup site in Omaha. So if it goes down, hopefully. So there's things that can go wrong with this. Typically, we send somebody home and they need to work, and then we run into this issue. Their internet service provider. How fast are they? Do they have bandwidth? How often are they down? And I will tell you, living in the armpit of our state, or in southeast Nebraska, we have established that in a lot of cases, these providers have a single path all the way back towards Lincoln or Omaha, wherever they're pulling data from. So there's not a loop. There's no way for them. So a single backhoe at the edge of Lincoln takes out the entire corner of the state for spectrum, for example. That happens repeatedly. You're supposed to be working at home and you don't have an internet connection. What do? It's a problem, internet service connection uptime. So you need to be aware of that. And so if you're going to make people responsible, figure out sometimes a backup plan. So we actually have a cell phone service that we use on a MiFi. It can't do everything that my data connection do, but Sunday night my internet goes out. What do? Somebody digs a hole. You kind of have to worry about that. You also have to worry about that provider. Do they have downtime? Does Google have downtime? Yeah. We've experienced that. Does Amazon Web Services? Yeah. Did our Blackboard, have we had issues with that? Actually, the issues this year, and you've seen a couple of them where you couldn't log in, was actually at UNL on our single sign-on service. It wasn't actually Blackboard. But to us, does it matter? You still can't get into Blackboard and do your work. And it's always when we put off that assignment to the last minute, and suddenly, damn it, Blackboard's down. All right. So I feel you on that one. It happens. So you have to make sure, or what about their backup and security system? You're putting all your eggs in somebody else's basket. Do you trust them? We've had issues. Amazon Web Services, some people have misconfigured it, and it wasn't necessarily Amazon's fault. But if a vendor misconfigures their web services and allows all the data to be accessible by a common password, so we've had some data breaches. We've had data breaches that are the fault of companies like Amazon and other ones. And so millions of passwords are floating out there. It only takes one bad employee. Well, crap. Do I control those employees at Amazon? No. We need to worry about data regulations for our industry. So if we're in healthcare, we have HIPAA to worry about. If we're in education, we've got FERPA and several other laws to worry about. And if we're doing the financial aid piece, we have a whole nother list of things we got to worry about. So we got to make sure that whatever we're doing doesn't cause an issue due to security, regulations. So I've worked with several smaller hospitals. Hospitals are weird. They tend to be very siloed and have all their data still on premises. And part of the reason for that is they're paranoid about that data leaving their site. And the boards who can ultimately control some of that have to approve it say, oh my goodness, well, I'm not sure that I understand things like encryption. I'm not sure that I understand this data that just magically goes out to the cloud. And so you do have, sometimes you have issues with that. Who owns some of this data becomes an issue. And data maintenance. So there's some other ones I think we need to worry about. So we think Amazon's not going to go out of business. What if they do? What happens to all of our data on Blackboard if they go out of business? What happens to you guys as students? Amazon goes out of business, or Blackboard goes out of business, or they forget to pay the bill to Amazon. They go bankrupt. Oh. So, we have to be cautious of that. The other one that is a little frightening now, we have all these devices and people want to do things. People want to get their jobs done, and so they look for the most efficient way to do it. Sometimes the way they do that is against several of these regulations. So, man, I'd like to communicate with my coworkers, and I work for a financial services business, so I just start messaging them over Facebook Messenger because that's convenient. Is there a problem with that? Yeah, so in a lot of cases, all those transactions and logs need to be tracked, and you're putting it out on a third-party app that we don't have the ability to monitor and maintain. So companies will say, all right, we're going to put in our own chat messaging servers and other things so that we can at least have a record of that. So we do have to be careful of that. People have gotten burned very badly in companies by trying to do the right thing, but they put data in the wrong spot. So hypothetically, if we took our data, we're going to go to a trade show. And man, I have all this data I'd like to show about these medical patients. So I load it all up on my laptop, or I set it up in a cloud environment. I send it in a Google Drive so I can access it in Las Vegas at a conference. What's the harm in that? So it's that same idea that data's left my control. It may be data that really shouldn't be seen by other people. I've breached confidentiality. I maybe have breached FERPA or HIPAA or whatever group I'm working with. But I've seen that happen. And so you have to be really, really careful about that. So, how can I fix cloud computing? Well, it's not going away. We're going to be using it. So, a couple of really important tips. Encryption. So, how I connect to it is in some ways less important than the fact that I'm end-to-end encrypted. So whatever vendor I'm using has to tell me that I'm end-to-end encrypted. In other words, that data is scrambled, and we'll look at some of those models for scrambling it, but it's got to be scrambled. It has to be encrypted. So there's something called the CIA triad. Has nothing to do with the CIA that you think of and spies, but it's that idea of confidentiality, integrity, and availability. We need to have all three things. It's a triad. We want our data to be confidential. We want it to be integral, in other words, whole, and we need it to be available. So one of the ways we do that is using what we call key encryption. So you guys have all probably done key encryption as a child. When you made a note to your buddies and you wrote out the alphabet and you put a letter and a number below each one of them, and so you said, let's see, H is 8 and I is 12 or whatever, and you wrote a note that said 812, and that's a kind of form of encryption. You're scrambling that data. Well, that one's not very tough. But we can build encryption that is tough. The problem is this. We have private key and public key encryption. Private key could be, in theory, even better, except it uses a single key, and it's known only to the sender and receiver. The problem is, so you encrypt and you decrypt with the same key. The problem is, how do you get that key to somebody else? Because if I send it via email, what if somebody grabbed that email? They're able to decrypt all the same stuff we are. So what we have settled on, or made, which is actually a better way to look at it, is public and private key encryption. So you have two keys to preserve your data. You have a public key, and everybody knows the public key. You can put it on a website. Here's my public key. You have a private key. So anybody can have the public key, you only have the private, and then there is a server that just hands those out. You can put it on a website, there's servers available for it. Together, that public and private key make a pair. And it's what we call asymmetric. In other words, it takes two different keys. So a different key to encrypt than it is to unencrypt. This is what the best way we have. This is how your websites work now. If you see the little padlock, it is a private public key. if you've got an encrypted email, regular email is not encrypted, but if you're doing encrypted email, you're doing that. We also have this idea of certificates. So websites use the idea of certificates, and we use them for our own stuff also. But certificates saying this is really what this website is, or this is that data it really does belong to. So to get a certificate, you pay a vendor, so there's hundreds of them, who have the ability to verify who you are. So Peru State College has a digital certificate. It's a set of numbers, and it's got a public and a private section. And it says, this is who I am. I verified that that's who I am. So you can't just go out, put your credit card in, and get one immediately in most cases. They have to verify that's who you really are. So that forms, they're issued by that certificate authority. So we have to find a way to encrypt these communications. And so the most common method we use is something called IPsec. So IPsec, you don't need to know all the details for this particular class, but what it really does is creates a link between where you're sending and you, and it manages that connection. So it says, here I need to connect. It negotiates the security, sends the data, and most importantly, it ends the transport at the end. So it doesn't stay open. The most common thing you're going to use is this idea of secure sockets. So this is that little padlock. So web forms, you go to the bank, and in fact, some companies like Google would like every page, whether it's got important data or not, to be encrypted. And if you go to a website now that's not encrypted, a lot of times you'll see an error come up and say, hey, this site is unsecured. That just means that it doesn't create that connection. So this has got a handshake, kind of similar to that TCP handshake. So you'll see SSL or TLS, Transport Layer Security, or Secure Socket Layer. So there are some others. There's something called DTLS. So DTLS is very similar. Where this one gets done is by something that is time sensitive. Conventional SSL doesn't care about time. It says, I don't care. I'd be more worried about security. DTLS allows you to reorder packets, send them in a better manner. And so things like VoIP or video, if we need a secure connection, this is a little better option. Most of this is done behind the scene, though, and you don't actually see any of it. Last week, I actually asked you to find a remote service. And so some of you in the discussion board found some really interesting ones. That idea of remote access. We see this a lot. So now COVID has hit. People have to work at home. They'd like to just connect to that computer that they have sitting in their desk. We can do that. We can do that. And so we looked at a whole bunch of them in there. People mentioned my Team Viewer. They mentioned Connect Anywhere. So before we head off for today, I want to show you the one that I like and that I actually pay for. So, chunk. I actually use one called Splashtop. And so, in this case, I use it for a lot of different purposes. So, here, I've actually connected back to my desktop. Let me drag it over if I can. So, this is actually my desktop on my computer in my office, right over there. So, I can do anything I need to, and it looks like I'm sitting right here in front of it. And in fact, because I have multiple monitors, I can switch monitors around. So this is another version. Splashtop runs me, I think I'm paying about $200 a year for the features that I subscribe to. But it makes my life really easy because I have one command interface that I can get to any of the machines that are in there. It this particular version does require to install a small piece on each computer. They have a version that they call it SOS Rescue or something, and I haven't decided to spend the extra money. It's about $600 if I remember right, where I can have them type in a code. In this case, I can do unattended access back to my own computer, and I use it for a lot of that. So if I want to get into my wife's computer because she wants to show me a slideshow, we can actually access it that way. So this is one I use. It isn't necessarily always the best. There's a lot of different versions out there, and if you need just one or two computers, this is probably a little more money than what you're willing to or wanting to spend. On the other hand, something like TeamViewer, if you actually buy it, is about $1,000. Now it says, hey, you can have a free session for your home use, but if you're using it in any kind of business fashion, then you run into an issue. All right. So on Wednesday, we'll finish out the rest of this chapter, and we'll look at that virtual technology. So I will see you on Wednesday.